19 hours ago, Typhoon Fong Wong devastated the Philippines. 18 dead, 1.4 million homeless, villages washed away. But what terrifies scientists now isn't just its power. Unprecedented anomalies inside the typhoon's core are defying every known forecasting rule, pushing Taiwan toward a disaster no one saw coming. What's truly forming inside this storm? And what do experts fear most as Taiwan counts down to impact? At sunrise, the banks of the Cagayan River were gone. Entire neighborhoods in northern Luzon disappeared beneath brown, churning water. Official bulletins counted at least 27 lives lost, children swept from arms, elders trapped as homes collapsed, and families who never made it to higher ground. The storm's path left more than 1.1 million people without shelter. School gymnasiums, churches, and government halls filled with evacuees, many carrying only what they could grab in the dark. In Bicol, a barangay responder named Tomas led his team door to door, urging families to leave before the floodwaters rose. He remembers wading chest-deep through alleys, shouting above the wind, guiding a grandmother and her grandchildren to the last truck out of the village. The government's early warnings had spurred a massive evacuation, the largest since the last major typhoon. But the speed of the flooding caught many off guard. In eastern Cagayan, a provincial hospital became an island. With floodwater rising by the minute, staff carried 42 patients, some on stretchers, others in wheelchairs, up narrow stairwells, hoping the upper floors would hold. Over 86 ports closed nationwide, stranding more than 6,600 passengers and crew. Highways vanished under landslides, bridges twisted and torn away, power failed for hundreds of thousands, and entire provinces lost contact as cell towers toppled. For those left behind, the only refuge was a rooftop or a neighbor's second story. Relief workers moved from one crowded shelter to the next, distributing bottled water and plastic sheets. In the faces of the displaced, farmers, teachers, children, there was exhaustion, but also the quiet calculation of what they had lost and what they might return to. The scale of the disaster stretched beyond numbers. Each evacuee counted in the official tally carried their own story of escape, loss, and the uncertain wait for the waters to recede. Across the rice plains of central Luzon, a devastating surge of water swallowed entire fields. The Department of Agriculture tallied over $170 million in crop and livestock losses, with rice paddies, weeks from harvest, flattened and drowned. Farmers who had gambled on waiting out the storm returned to find only stubble and silt, their years' work erased in a single night. In Nueva Ecija, fields that once promised a record yield became shallow lakes, the grain rotting beneath the surface. Livestock pens, too, were swept away or left empty, with thousands of animals missing or dead. The storm's impact stretched far beyond the countryside. In the city of Tuguegarao, floodwaters climbed the hospital steps. With the ground floor submerged, staff and volunteers carried 42 patients, some on oxygen, some too weak to walk, up darkened stairwells to safety. Medical supplies ran low as power outages dragged on, and roads vanished under mud and debris. Emergency crews struggled to reach those cut off, as landslides blocked the main highway north and bridges collapsed into swollen rivers. Relief convoys rerouted again and again, detouring through towns where only rooftops marked the outline of what had been neighborhoods. Ports along the eastern seaboard remained closed for days, severing supply chains and isolating entire provinces. The closure of 86 ports left more than 6,600 travelers and workers stranded, their journeys halted by a sea too dangerous to cross. Power failures rippled across the region, plunging hundreds of thousands into darkness while cell towers buckled under the wind, silencing lines of communication. In the aftermath, the cost was not just counted in damaged roads and ruined harvests, but in the uncertainty of what could be rebuilt before the next storm arrived. The disaster laid bare the limits of infrastructure built for gentler times, as communities faced a future where recovery itself grows harder with every storm. Beneath the surface of the Western Pacific, a hidden reservoir of energy was quietly building. Oceanographers tracking Typhoon Fong Wong's path noted something extraordinary. Temperatures 2 to 3 degrees Celsius warmer than average, not just at the surface, but plunging from 100 to 150 meters deep. Argo floats and moored buoys along the Kuroshio Current relayed profiles, showing mixed layers far deeper than the seasonal norm. These warm pools, stretching from just east of Luzon to the waters off Taiwan, acted as a vast thermal battery, fueling the storm with a steady supply of heat even as it churned up the sea. Dr. Lin Mei Ling, a junior meteorologist at Taiwan's Central Weather Administration, was among the first to flag the anomaly. Reviewing real-time buoy data, she watched as sea surface temperatures stayed stubbornly high in the storm's wake, refusing to cool as expected. The usual upwelling of cold water, which often saps a typhoon's strength, barely registered. Instead, vertical mixing brought more warmth to the surface, keeping the ocean's energy available for Fong Wong's core. Satellite altimetry confirmed the picture. Dynamic sea height in the Kuroshio region was up by more than 10 centimeters, a clear sign of deep, warm water ready to be tapped. In these conditions, the typhoon's engine ran hot, resisting the weakening that forecasters had predicted once it crossed land. The deeper the storm reached, the more fuel it found, rewriting the limits of what scientists thought possible for typhoon intensification. Radar loops from both the Philippines and Taiwan revealed a storm core behaving unlike anything in recent typhoon memory. Instead of the usual 12 to 24-hour interval between eye-wall replacement cycles, Fong Wong tore up the rulebook, cycling its eye-wall structure every 6 to 8 hours. Meteorologists watched as the inner eye wall would contract and erode, only for a new, stronger outer ring to snap shut around the core in less than half a day. Each time, the storm's main wind field expanded, and the central pressure barely budged. Satellite microwave imagery and Doppler radar tracked these shifts in real time. One moment, a single tight eye. The next, two concentric rings. A Russian doll of swirling convection, each feeding off the ocean's heat and the atmosphere's moisture. At latitudes where such double eye walls are rare, Fong Wong kept building redundancy into its structure. When the inner core weakened or brushed against Taiwan's mountains, the outer ring took over, keeping the cyclone's engine running at full throttle. This pattern baffled forecasters. Standard models predicted a drop in intensity with each replacement, but Fong Wong seemed to gain strength, not lose it. The storm's ability to regenerate its core so rapidly meant that, even as land and wind shear tried to tear it apart, there was always a backup ready to keep the circulation intact. For scientists, these rapid, nested eye wall cycles were not just a curiosity. They were a warning that storms that could now maintain their power in ways the old forecasting playbooks never imagined. A ribbon of vapor stretches from the Indian Ocean to the heart of the typhoon, channeling more water than most rivers on Earth. Meteorologists call it an atmospheric river, a narrow band of air so saturated that it can deliver 15 times the moisture of the Mississippi. This invisible superhighway feeds directly into Fong Wong's circulation, transforming what should be a regional cyclone into a weather engine with continental reach. Dr. Tseng, at National Taiwan Ocean University, has tracked its progress for days, watching as satellite data shows the river's plume connecting thousands of kilometers of open ocean to the storm's core. The influx isn't just a one-time surge. Climate models reveal that these moisture-laden air corridors are becoming more frequent and more intense. Since 2010, the depth of the Western Pacific's mixed layer has nearly doubled, allowing storms to draw energy longer and with less interruption. The result? Storms like Fong Wong can hold together, reload, and dump record rainfall even after crossing land. Projections from leading climate centers warn that by 2050, storms with this kind of external fuel line could increase by as much as 40%. What was once rare is becoming the new normal. Storms that don't just intensify but rewrite the limits of what atmospheric rivers and ocean heat can deliver. The threat now stretches far beyond Taiwan's shores, hinting at a future where the scale of disaster is not just local, but global. Warnings from Taiwan's Central Weather Administration arrived with numbers that left no room for doubt. Along the east coast, authorities braced for waves as high as 6 meters, enough to overtop seawalls and swallow entire fishing ports. In low-lying districts, the threat was not just the wind. Rainfall projections showed 200 to 400 millimeters falling in less than 24 hours, with some mountain valleys expected to see even more. These totals matched what most rivers in the region would handle over several months, now packed into a single day. For the 23 million people across the island, the risk map was everywhere. In Yilan and Hualien, emergency officials tracked rising river gauges and issued red alerts for flash floods and debris flows. The Water Resources Agency mapped out the worst-case surge zones, coastal plains, river mouths, and old landfill sites where drainage systems were already straining under the first wave of runoff. In Mingli, a village perched above a barrier lake, the memory of past disasters hung heavy as families watched the water climb toward the main road. Schools closed in anticipation, sending hundreds of thousands of children home with instructions to pack emergency kits and stay indoors. Hospitals and care homes moved patients to upper floors, while local governments activated text alerts warning of possible evacuation orders at a moment's notice. Even in Taipei, far from the direct path, officials urged residents to prepare for sudden power cuts and road closures as feeder bands swept across the capital. The numbers told a story of compression, of time, of space, of risk. 4 to 6 meters of surge could erase the line between land and sea. 200 millimeters of rain could turn a hillside into a river. For those in the path, the countdown was measured not in hours, but in centimeters of water, in the rising pitch of wind, and in the knowledge that the next warning might be the last chance to move to safety. Sirens echoed across Taiwan's east as evacuation orders swept through communities from Taitung up to Hualien. In the span of a single morning, more than 8,300 residents packed bags, boarded buses, and left behind homes perched on slopes or nestled along swollen rivers. The government's alerts arrived by text, radio, and loudspeaker. Move now, before roads disappear or rescue becomes impossible. In Mingli, families recalled the panic of 2009, when Typhoon Morakot's landslides buried entire villages. This time, officials mapped out hazard zones in advance, marking neighborhoods at risk of flash floods and debris flows. Troops and civil defense teams fanned out, checking on the elderly and driving those without cars to designated shelters. The threat in the mountains went beyond rising water. Taiwan's steep terrain, carved by centuries of rain, is prone to collapse when saturated. Geologists flagged dozens of slopes as unstable, especially where recent earthquakes had loosened the soil. In Hualien County, a barrier lake, formed by a landslide upstream, became a ticking clock. If the makeshift dam gave way, a wall of mud and water could sweep downstream with little warning. Emergency crews stationed monitors and sent real-time alerts to villages below, warning that even a distant rumble might mean it was time to run. Local governments activated their debris flow alert system, a network of sensors and spotters tracking rainfall and ground movement. In at-risk townships, school gymnasiums and public halls filled with evacuees. Some carried pets or livestock. Others arrived with only their documents and a change of clothes. Volunteers sorted out bedding and hot meals, while medical teams checked blood pressure and handed out medication to those forced to leave in a rush. The logistics of moving thousands in a matter of hours tested every part of the emergency plan. Landslides blocked mountain roads as convoys tried to pass. In coastal towns, buses detoured around flooded intersections, racing the rising tide. For every official counted in the evacuation tally, there were others: farmers, migrant workers, the homeless, who made their own way to higher ground guided by memory and instinct. As the wind picked up and the first sheets of rain swept in, the island braced for the unknown, each community hoping that this time preparation would be enough. When sustained winds reach 60 kilometers per hour, evacuation orders are no longer a suggestion. They are a signal to evacuate. At this threshold, roads become dangerous, power lines can snap, and emergency crews may not be able to reach you. For families in Taiwan's eastern counties, the first step is clear: move to designated shelters or to higher ground as soon as the warning is issued. Do not wait for visible danger, because by then escape routes may already be cut off. Every household should have a 7-day emergency kit ready before the storm arrives. That means at least 2 liters of water per person per day, shelf-stable food, a flashlight with spare batteries, a battery-powered or hand-crank radio, and a first aid kit with any prescription medicines. Pack copies of identification, a small amount of cash, and a power bank for your phone. Rain gear, sturdy shoes, and a whistle for signaling help are essentials, not extras. For families with infants, elderly people, or pets, add extra supplies. Communication is just as vital as supplies. Write down emergency contacts and meeting points in case your family gets separated. Charge all devices before the power goes out. When the alert comes, leave early. Do not risk waiting until the wind and rain are at your door. Rebuilding for a new era of storms means confronting the limits of yesterday's defenses. In Taiwan, engineers and scientists are pushing for drainage systems built to withstand 500-year floods, a leap from the 100-year standards that failed during Morakot, and again under Fong Wong's deluge. The Water Resources Agency is drafting plans for supercharged culverts and levees, recalibrated for rainfall rates that can deliver 700 millimeters in less than 2 days. But hardware alone can't keep pace if the data behind the warnings lags behind reality. To close the forecasting gap, meteorologists are expanding high-resolution models with 3-kilometer grid spacing, able to resolve the narrow bands of rain and wind that decide which valley floods and which stays dry. These models demand real-time input no surface station can provide. That is why oceanographers are racing to fill the sensor gap along the Kuroshio Current. New lines of moored buoys, equipped with thermistor chains and current profilers, are planned from Hualien south to Taitung, designed to track deep ocean heat, the same fuel that powered Fong Wong's intensification. International partnerships are supplying underwater gliders and satellite uplinks, building a sensor network that can feed the next generation of typhoon models. For the scientific community, the challenge is clear: adapt faster than the storms are changing. That means not just rebuilding infrastructure, but rethinking how risk is measured, how warnings are issued, and how the unseen forces beneath the waves are tracked. Every hour gained in prediction, every centimeter shaved off a flood crest, is the product of a system that learns from its failures and refuses to be caught off guard again. Today's storm isn't just a warning, it's a preview. As ocean heat breaks records and typhoons adopt new, unpredictable behaviors, the systems we trust to keep us safe lag dangerously behind. Scientists now face storms that no longer follow the old rules. For millions in the path, adaptation isn't optional. The climate's new playbook is already being written, faster than we can read it.